Hey guys, Kevin here. Welcome back to a new video on NumPy. So we're going to be having a look at NumPy arrays, and NumPy arrays is basically a substitute for the lists that we had in Python. Alright. So whatever work we were using lists for, NumPy can do the same work along with some additional operations. And the NumPy arrays that we use are way faster. They occupy way less memory inside the machine, and and you can perform loads of operations on NumPy arrays easily, for which on lists you would have to do a lot of work. And that's why for machine learning, whenever we are doing some operations, whenever we are performing certain things like regression and all, we tend to use NumPy arrays instead of lists or instead of some other data type. Right, and that's why it's essential to learn NumPy. So let's get started with NumPy. Now, in order to load NumPy is a library. So the way we imported pandas as PD, similarly we're gonna import NumPy as NP. All right, so that's easier. We don't have to write NumPy dot function name each time. We just write NP dot function name. All right. Now, to initialize an NumPy array, you declare your entire list. All right. The way we are declaring lists, we are declaring lists by a code like a equals to 1 comma 2 comma 3. All right. You do the same thing, and then what you do is you take a function you call NumPy. You say NumPy np dot array. You create an array function and enclose the list inside the parentheses of the array function, and that is how you can declare your NumPy array. Alright, so this is how we'll declare a NumPy array, and let's print it. So let's run, first we'll need to import NumPy. So let's run this. Alright, so NumPy has been imported. Now let's run this. So now A is a NumPy array with the values 1, 2 and 3. Alright. Now if you remember, in Python lists we had 2D lists, we had 3D lists as well. Alright. So over here in arrays as well, we have got 2D arrays and 3D arrays. So to initialize 2D arrays, it's similar how we were initializing 2D lists. We were creating a list, we're creating sublists inside one major list. All right, so that was your 2D list. Over here, similarly, you call the np.array function. Inside that, you create a big list, and inside the list where you put the elements, you put sublists. Right. So that's how you can declare 2D arrays. So let's run this. There you have it. All right. Let's run this now for 3D arrays as well. What is 3D? Okay, let's have a look at this. 1D arrays is one line of values. All right. 2D arrays is a table. So you have got one row and then you've got another row. So that's a 2D array. It's basically a table. And if you were to stack these tables on top of each other, that will become a 3D array. All right. So you take one row, you put another row to it. All right, in the same domain, in the same plane. So you got a graph, you got a table. All right, you got a x and y table. You got rows, you got columns, and then what you do is you take many of these tables and you stack them on each other, and that will create your 3D array. So that's basically what is happening over here. We created a table, all right, and that table was along with another table. We created a table and that was along with another table, and those tables were stacked over each other. So that created your 3D array. Now to get the dimension, now let's say you declare an array. Instead of declaring, you just fetch an array from somewhere. You want to check what dimension is there of that array. You will just run the .endim command. All right, use that a.endim function, and that will tell you what is the dimension of that array. So a is 1D, 2 is b is 2D, and c is 3D. So that is done using the .endim function. All right. Now, what is shape, you might ask? A shape of an array is the number of rows it has and the number of columns it has. All right. So if you want to do that, we have got the dot shape function. So let's run that. So in 1D arrays, it's always a 1D array is always stacked vertically. All right. So you always have got rows but no columns. It is one specific column, and then values are put as new entries. For 2D arrays, you got rows obviously, and then columns, long columns of your arrays. Right. So that's your 2D array. And even for 3D, let's do c dot shape. All right. And as you can see, it will go into the third dimension. So c dot shape is 2 comma 2 comma 3. So you got two tables, each with two rows, and with 3 columns. All right. So let's move on. Now, if you want to get the data type of your array, all right, like what value you have stored inside the array, if you want to get the data type of that value, you just write a dot data type. So in A we had used integers, all right, 1 comma 2 comma 3. However, in B we used floating points, all right, we used decimals over here. So for B dot data type it will return float 64. Over here for A dot data type it was int 64. Now let's say you want to get the item size, right? Let's say you want to get the size of each item. So over here we had put 1 comma 2 comma 3. So what is the size of 1? What is the size of 2? If you want to get that, you can use a dot item size and it will tell you the size of each item present in the array. For in the case of A and B, we had int and float, both occupy 8 bits. So any integer A or any integer 1 or 2 or 3, that will obviously occupy 8 bits. So that is the output. If you want to get the total size of your array, so total size is 8 plus 8 plus 8, that is 24 in the case of A, and in the case of B I think we had 6 values. Yeah, in the case of B we had 6 values, so that will be 6 into 8, that is 48. So let's run that. Dot n bytes will give you the size of the entire array, so 24 and 48. So that's how you can get the size of the entire array using .n bytes command. Yeah, so that's it. Let's move on. So now let's have a look at accessing and changing specific elements of an array. So let's say you've got your values in an array and you want to access some specific value or you want to change that specific value, what we can do. So let's say I've got a 2D array called A with one sub array having values from 1 to 7 and the other sub array having the value from 8 to 14. Right, so let's print that and let's have a look. Yeah, so there you have your array. Now let's say you want to get a specific element. You will do A square brackets row comma column, right? uh, and that will give you the output of that value. So over here you got the row at index 1 and the column of index 5. So that's your second row and your sixth column. So there you have it, 13, and 13 has been returned. Now let's say you want to get a specific row. You will just put the name number of the row, the index of the row, and then for columns, because you want the entire row, you will put a colon which will indicate all of the columns present. So let's run that. This will be the first row. So this is your first row present over here. Let's say you want to get a specific column. Right? I should change this. Get a specific column. All right. Uh, yeah. If you want to get a specific column, you will say that because I want these column, I want all of the rows to be present and the column index. All right. So over here the column index is 2, so we should get the third column, that is 3 comma 10. Yeah, there you have it, 3 comma 10. And the fun part is it will return that value as another array. All right, it will return the value as a 1D array to you. So if I were to store this as, let's say, let's create another cell, let's copy this and let me write k equals to a. All right, so that's your new variable k. And what is k dot uh, endim? All right, what is k dot endim? Let's run that. Yeah, it's 1. All right, so whatever value that is returned by this a and square brackets is always a 1D array. So that's something you should remember. All right. Let's move ahead. Now let's say you want to get specific elements or specific numbers from the entire row. You mention the row and then you use start index and plus 1 index. All right, so from where to where and which number of elements you have to skip. All right, so let's run that. So 1 to 6, right? You want 1 to index number 6, and then you wanna skip each second element. All right, so you wanna skip 1, you wanna skip 3, you wanna skip 5, you wanna skip 7. All right, so that's why we got 2 comma 4 comma 6. All right, so yeah, that's it for getting specific values. You can also, this is known as slicing as well. Slicing works over here as well. slicing as we did in strings and lists. So slicing can also be used in NumPy arrays. Uh, Now this was accessing specific elements. To change these elements, it's pretty much the same thing. You access that cell and then you give it a new value. You assign it a new value. So let's say I want to assign the value 69 to the element present in the column in the row with index 1 and the column with index 5. So I think that's your number 13, all right? Row index 1 and column index 5. So that's 12, sorry, it's 13, all right, 13, column index 5 is 13. So let's run this, and what we should see is that instead of 13 you got 69 over here, right? Similarly, if you want to change the entire column, you will say all rows and the column at index 2, so that's the third column, and both of them are now 69. Let's say you want to assign specific values to some of the elements that you have selected. What you will do is you will say that I want all the values of a particular column, let's say at index 4, and I want to change them with 1 comma 2, whatever value I want to put. If I were to put 5 comma 10 over here, they'll get changed with 5 comma 10 as well. We had put 1 comma 2 when running the program, so we've got 1 comma 2 over here. Let's copy this code cell, let's create a new one, let's paste it over there, let's run that, and there you have it, you got 5 comma 10 instead of there. So that's how you can change a specific element. So for 3D arrays, it's the same thing as we did in 2D arrays. What we'll do is we'll again access that element and then we'll assign it a new value. Alright, so let's create a 3D array called B, and it will have the values 1 2 3 4 in one table, and then 5 6 7 8 in another table stacked upon each other. Right, so 3D array in that way. Let's say I want to access table number 1, table at index 0, so the first table, or let's work with indexes only. Table at index 0 and the row at index 1 and the element at index 1, so that's 4. Let's say I want to access 4. What I can do is I can say table number, so that's 0, row number, that's 1, and element number, or rather I should say column, because we are working with tables. Tables make more sense when they are in rows and columns. So table number, row number, and column number, right? And if I do that, I should get the answer as 4. Let's say I wanna access 7, right? So pause the video, think of it, how we can access 7, and I'm just gonna say it. So for 7, it will be table number 1, row number 1, column number 0. So it should be 1 comma 1 comma 0. When we run that, we receive the answer as 7. Alright. Now let's say I wanna replace a specific element. Alright. Let's say I wanna replace in both the tables. In both the tables, on the second on the row at index 1, right, and both the column values. Let's say I want to do that. So I want to basically change 3 comma 4 and 7 comma 8. If I want to change those, I can mention the replacing values, that is 9 comma 9 and 8 comma 8, and if I run this function, we receive the new b, which is 9 comma 9 8 comma 8. So that's how you can replace elements. Just access them, give put an equals to value, and just write the new value that you want, all right, in whatever format it is. Let's say if it's 2D array or 3D array, it's up to you, right? Now let's have a look at initializing arrays. All right. So many times when you're working in when you are in a hurry, and let's say I want to create a matrix which has all values as a specific number. All right. So all the values in the array should be either 0, either 1 or 2, 3, 4, whatever. If I want to do that, there are some functions that have been predefined in NumPy through which you can do that. All right. So how you will work with that? You will say NumPy dot zeros function, and then you will mention the shape of the array that you want. You'll mention the shape of the array. So 2 rows, 3 columns, right? 2 rows, 3 columns. And what you should receive is that you should receive an array with 2 rows, 3 columns, and all of those values would be 0. So let's run this. And there you have it. You have a 2D array with 2 rows and 3 columns. Let's say I want to create a 3D array with 2 tables, and each table having 3 comma 3, being of 3 comma 3. So let's do that. And there you have it. You have a 3 by 3 table with 0 values, and you've got 2 tables stacked upon each other. So that's how you can create all zeros array using by just providing the shape and using the zeros function. All right. Let's say you want to do that with where you want to replace all the where you want all the values to be 1. All right. So similarly, you will put the shape, you will write the ones function, and what you receive is a 3D array with 4 tables, each table of having 2 rows, 2 columns, and all of them having the value 1. Now let's say you want to do that for any specific number. All right. Now we can't go on creating functions 2s, 3s, 4s, 5s. No, that's not something you want to do. So there's a function called full where you mention the shape, you put a comma, and then you write the number that you want. So let's run that, and what we should receive is we should receive a 3D array with 3 tables, 4 rows, and 9 columns, all having the value 4, and that's what we received. All right. Now also in some cases, let's say you've already got a predefined array. All right, let's say it's already defined, or you have fetched it from somewhere, and what you want to do is you want to create a new array where it should have the same shape as the earlier array, but the values should be a specific number. So what you'll use is you will use the full underscore like function. So it's basically the full function. However, you are giving, instead of giving the shape instead of giving the shape on your own, you ask it to inherit the shape from another array. So we had got a over here. All right. uh, A was this 2D array. All right, this was the 2D array A, right, with 2 rows and 7 columns. uh, let's take that A. All right, let's print that so that we can have a look at it. Yeah, 2 rows and 7 columns. And what we want to do is we want another array of the same shape, so having 2 rows and 7 columns, but all of those values should be 4. So let's run this, and there you have it. All right. Um let's move ahead. Let's say you want a array of a specific shape, but all of them should be random decimal values. Random decimal values. It should be any value which should be a decimal. You mention the shape, you use a numpy.random.rand function, and there you have it. You got a randomized decimal value array of the shape that you wanted. Let's say you want to fill them with random integers. You use the same function. You use, instead of using just rand, you put a rand int, all right, random integer, and what you do is you give a range. You give a range of values that you want. So let's say I want the values from 0 to 15. All right. uh, what I should receive is I should receive a 3 by 3 array having random integer values from 0 to 15. Let's say I want to do -4 to 7. All right, -4 is also an integer, -7 is also an integer. If I do that, and if I run that, yeah, all the values that are all the randomized values that are present in this array would be in the range of -4 to 7. All right. Yeah, so that's it. Now let's say I want to create an identity matrix. If you are not familiar with identity matrix, these are matrices which have all the diagonal elements as 1 and the remaining elements as 0. So if I want to do that, and also all the in an identity matrix, the number of rows and number of columns is always same, always equal. So we'll just mention one number, that is 4. So I'll get a 4 by 4, 1 on 1, 1 as diagonals, and other values as 0. So let's run that, and there you have it. Let's say I want to repeat an array multiple times. So let's say I have 1 to 1 comma 2 comma 3. All right, I want to repeat it 3 times. So I want something like 1 1 1 2 2 2 3 3 3 in a long array. 1 on 1 2 2 2 3 3. What I'll do is I'll use a repeat function, and then I'll say that I want it to be repeated 3 times or 4 times or how many times I want, and then I'll print r1. So if I do that, I should receive 1 on 1, 2 to 2, 3 to 3. So it will repeat each element of your array the number of times you want it to. Alright. Similarly for 2D arrays, now in 2D arrays, thing is you can either arrange them in a horizontal manner. Alright. So basically create a 1D array with only one row. Alright. And either or else what you could do is you could stack them on top of each other. So you could create each you repeat the input array in different rows. All right, you could do that. So for that you will use axis equals to 0, and what that will return to us is a vertically stacked array. All right, array with dimensions as 3 rows and 3 columns. Or else if I were to mention axis as 1, it will return to us the same output as the above function. All right, it will give us a 1D array. So let's just keep these as axis equals to 0, and yeah, let's move on. So now there is an important aspect with variables and arrays. So earlier when we were learning Python, let's say I were to create a integer kev with the value 50. All right. Now what I want to do is I want to create another integer, let's say Dave, and I want to give it the value of kev. And what I want to then do is I want to add 50 to dev. All right. So dev equals to dev, that's 50. All right. Let's say I want to do that. And if I were to print dev and print kev, what would happen is that dev would get the value 100 and kev would get the value 50. All right. So what we did was we created a variable, gave it the value whatever we wanted. Then we create another variable and we gave it the value of the initial variable, and then we made some changes on the second variable, and then what we received as the output was that the second variable's value got changed and the initial variable remained the same. All right. Now in arrays, the problem is that whenever you do that, that's not how it works. All right. So let's have a look at this example. I create an array called a with the values 1, 2, 3, and then I assign a to b, and then the first element of b is replaced by the value 100. All right. So if I do that, technically I should receive A and B, A as 1, 2, 3 and B as 100, 2, 3. However, that's not the case. What we have over here is that B got changed and so did A. Alright, so that's how arrays work. In arrays, when you create a new variable and you assign it another value, these values get linked together. So whatever operation you perform on any of those, whatever operation you perform on A or B, both of the values will be affected. As you can see over here, when we change the value of the first element of B, 200, even the first element of A got affected. Now let's say you want to create a copy. What you will do is you will use the copy function present over there. So what you will do is you will say b equals to a dot copy, and if I run this, A isn't changed and B is changed. All right. So whenever you're copying arrays, you should always use the dot copy function. All right. Don't do b equals to a. Just do b equals to a dot copy. Now let's perform some basic mathematical operations. NumPy can do that as well. So let's say I create an array called A 1 2 3 4. Very very thoughtful of me. Very creative array. 1, 2, 3, 4. And let's say I want to add 2 to each element of the array. A plus 2. We got 3, 4, 5, 6. Let's say I want to subtract 2 from each element, a minus 2. Let's say I want to multiply each element with 2, a star asterisk 2. Alright, let's say I want to divide each element by 2, a by 2. Let's say I want to add two different arrays. Alright, let's say I want the elements at the same indices to be added. So the element at index 0 in A and element at index 0 in B should be added. Element at index 1 of B and of A should be added, and so on. I can use A plus B, and what we'll receive is we'll receive 2, 2, 4, 4. Alright. Now let's say I want to square each element of the array. I'll use a double asterisk and then the power. So if I want to square, it will be 2. If I want to cube, it will be 3. So let's run that, and you can see we got 1, 4, 9, 16. Let's say I did this 3. We'll receive the cube of each element. So 1, 8, 27, 64, and so on. Let's say I want to find the sign of each element present in the array. np.sign. Right. There are many such operations that can be performed on arrays. You can have it's difficult to put them all over here, so I've mentioned the main ones, and then if you want to have a look at other functions, you can go to the documentation of NumPy. All right, and all of these functions are available for you. They're pretty simple, and they also will tell you how you can, what's the syntax for them. So everything is present on the documentation. Let's move ahead. Now let's say you want to perform some linear algebra. So let's say you want to multiply two matrices. I've created a matrix A of the shape 2, 3 with all the values as 1, and B of the shape 3, 2 with all the values as 2. Alright. Let's say I want to multiply them. I'll use the matmul function. Alright, matmul function, it's readily available. It's also available in the documentation. Now to receive is we receive 6, 6, 6, 6. So that's your proper matrix multiplication done very easily. Let's say I want to find the determinant of a matrix. Alright, so what I'll do is I'll create an identity matrix of the dimension 3, 3, and I'll assign it to the value C. So it will be 1, 1, 1, 0, 0, 0, all the other values. And let's say I want to find the determinant. So I'll use the linear algebra. So linear LIN ALG, linear algebra for short. NP dot linear algebra dot determinant function, and I'll give the value of c, and what we should receive is we should receive 1, so that's a determinant for any matrix. Candidate for any matrix is the function for that. Again, you can go to the documentation, I've given the link, and you can have a look at other linear algebraic functions that can be applied using NumPy. Alright, let's move ahead. Let's do some statistics using NumPy. So for doing statistics using NumPy, again, we'll create an array called stats. It will be a 2D array 1, 2, 3, 4, 5, 6. Let's say I want to find the minimum of this array, so that is 1. Let's say I want to find the maximum value, so that is 6. You'll use the max function. Let's say I want to find the sum of all the elements, alright. So that should be 1 plus 2 plus 3, whatever it is, 21, alright. Now let's say I want to find the minimum and the maximum on a particular row or column. So as I explained before, axis 1 is your row and axis 0 is your vertically column. So let's say on the axis 1, so in 1, 2, 3 and 4, 5, 6, I want to find the minimum. So I should receive 1 and 4 as the output. Yeah, there you have it, 1 and 4. Axis 0 is columns, so I should receive 1, 2, 3, alright. 4, 5, 6 because it's maximum, right? Max function. So you just use the same function as above, and you just give it an axis factor as well. So what axis you wanted to do it on, and sum again for axis 1 is 1 plus 2 plus 3 and 4 plus 5 plus 6. So that's how you can perform statistics. There are many more statistics functions available on the documentation. Let's say I want to change the shape of an array. So let's say I want to reorganize it. What I can do is I can let me just run this function for you. So I had got this array with 8 elements, and I wanted to change its shape from 4 comma 2 to 8 comma 1. So 8 rows and 1 column. If I want to do that, I can just use the reshape function, give it the new shape, and then I can just assign it to a new let's say I can just assign it to a new variable, new array called after, and what it should do is it should change that, make those changes. So let's say we've got 8 elements over here. We could also do 2 comma 4. So 2 rows. We've already got 2 comma 4. So let's say I want to do 4 rows and each having 2 columns, 4 comma 2, and let me run that. And what that will do is it will create 4 rows and 2 columns for me. So that's how you can use you can reshape these arrays. Let's say I have 2 separate arrays and I wanna vertically stack them. I'll use the np.stack function, and I'll mention both the arrays v1 and v2. And what that should do for us is it should create yeah, we printed v1 and v2 and then it stacked them vertically. So it created a 2D array for us where these were 2 different rows. All right. So now it has become a table. Let's say I want to horizontally stack 1D matrices. All right, let's say I want to do that. Let me just run this. Instead of doing stack over here, you will do h stack, and what it will do is it will create, add them like this and then put another value. So it will expand the table. All right. Yeah, and that's pretty much it for NumPy. All right, I have tried to cover everything. You can have a look at here in the table of contents. Under NumPy, I have done the basics, accessing elements, initializing arrays, copying arrays, basic mathematics, linear algebra, statistics, reorganizing arrays. Yeah, that's pretty much it for NumPy. All right, if you want to have a deeper look into NumPy, the documentation is open for you. There are loads of things available over here. Alright, all of these different things are available for you to explore. This is all the basic NumPy that you will need for machine learning, and I've explained all of it. So yeah, that's it for this video. Thanks for watching, guys. Leave a like if you enjoyed the video. Subscribe for more of such videos. Give me a follow on Twitter at Karia. And if you have any doubts, you can leave them in the comment section below, or you can send me an email at ask.kevinpgaria@gmail.com.